In this video, we're going to solve question paper 6.2 of 0620 chemistry, that is IGCSE chemistry of the examination series May-June 2024. But before we start, I'm going to show you a quick look at an app which we have for the IGCSE, which is full of resources. Here is the app, and you can see that this app have lots of things for you as a resource. You have topics, you have past papers with MS, you have revision test. Let's have a look at what is there in the topics. In the topics, you have lots of chapters. All these chapters will have study materials, that is notes, video lectures, subjective test, MCQ test, etc. For example, these are the notes of one of the small topic, which there are lots of other notes of all the topics according to the new syllabus. And here we have lots of video lectures. Plus we have separate tests for core and extended papers for all the topics. This is just one topic for which we have given this many tests, and for all the other chapters there will be lots of tests. Revision tests and revision tests are separate. These are just the worksheets. Plus we have the past papers with MS for all the last 5 years. So just go ahead to the website and download the app for a very small cost. You will have to pay, but yes, the link is given in the description. Just go ahead and download it. So here is question 1 of the question paper 6.2, and it says, when a mixture of calcium hydroxide and ammonium chloride is heated, ammonia gas is made. Okay, and here is the reaction given, where calcium chloride is formed as a salt, water and ammonia on its reaction. And ammonia gas is soluble in water and toxic. It's clearly written ammonia gas is soluble in water and toxic. Ammonia gas reacts with the hot copper 2 oxide to make nitrogen, and here again the reaction is given. A student makes nitrogen using the apparatus shown in figure 1.1, and here is the apparatus shown, where we can see that in the first tube the calcium hydroxide and ammonium chloride are reacted, and in the second tube the ammonia gas produced in the first reaction in the tube reacts with the copper oxide to form copper, water and nitrogen gas, and the nitrogen formed is collected here as shown. Now let's go ahead and see what are the questions following it. Okay, it says name the items of the apparatus labeled A and B. Now if you have a look at the apparatus, here the boiling tube is A. So boiling tube, I'll write boiling tube and not the test tube, because when we want to heat a substance, we use a boiling tube which is similar to test tube, but it is made up of hard glass so that it doesn't crack on heating. So generally for heating we use boiling tube and not the test tube. And in the B, you can see here it's labeled, so that is the measuring cylinder. Here we have used an inverted measuring cylinder to collect the gas. So here we have measuring cylinder used to collect the nitrogen gas. Now the B question is, the apparatus needs to be heated in 2 places. On figure 1.1, draw arrows in 2 places to show where the apparatus should be heated during the experiment. Now we can see that both the tube needs heating where there is a solid substance present. So here is one of the arrow drawn to show the heat, and second is this arrow on the copper oxide where the ammonia gas will be passing off. So the heated solid substance are going to react. The next sub question is, during the reaction a colorless liquid collects at the point marked X in figure 1.1, suggests the identity of the colorless liquid. Now let's go ahead and see where is X and what can be the colorless liquid. Okay, here is the portion where the colorless liquid X is collected. Now that's the first reaction. So here is the first reaction. One of the product is water, and if this tube is slanting on condensation, the water is going to get collected in the tube X itself. So here the colorless liquid is going to be the water, which gets collected in the first tube itself. The D question is, some of the ammonia gas passes over the copper 2 oxide without reacting. Suggest why none of this ammonia gas is collected in the item of the apparatus labeled B in figure 1.1. Now what are they trying to say is that we have ammonia gas also, which is passing through this tube and which is unreacted, so that may also get collected in the measuring cylinder along with the nitrogen, but it is not found along with the nitrogen. Now it's clearly written here that ammonia gas is soluble in water. So even if ammonia gas passes over the copper oxide without reacting, it's going to dissolve in the water. So we can write that ammonia gas is soluble in water, and so doesn't mix with nitrogen, collected over water it is. Okay, the equation is the student does not collect the first few bubbles of gas. Suggest why the first few bubbles of gas are not collected. Now the reason is that the first few bubbles is air. The first few bubbles is air. The reason being is that in the tube already we haven't created a vacuum, so it is already going to have some air into it, and on heating this air is going to pass from the tube to the measuring cylinder we have set up. So that's why the first few bubbles are going to be air and we're not going to collect it. The F question is, explain why this experiment should be carried out in a fume cupboard. Now it's clearly written that one of the product, ammonia, is toxic, and if that gets spread out in the lab, it's going to be toxic. So obviously we need to perform the experiment in the fume cupboard. So we can just write that ammonia gas is toxic. We don't need more explanation because it's just 1 mark and we have only one reason of ammonia, which is toxic. So now let's see what is question 2, because question 1 ends here. There's a blank page. Yes, here is question 2. Says a student investigates the reaction between aqueous aluminium chloride and 2 aqueous solutions of sodium hydroxide, solution F and solution G. Now understand, we're using aluminium chloride that's reacting with 2 of the solutions, different solutions, which is both sodium hydroxide, solution F and solution G. Solution F and solution G have different concentrations. So what's the difference? Both of it are sodium hydroxide, but the concentration varies. Now the experiment description is given here. It says rinse a burette with distilled water and then with aqueous aluminium chloride. Rinse a conical flask with distilled water. Fill the burette with aqueous aluminium chloride. Run some of the aqueous aluminium chloride out of burette. So the level of the aqueous aluminium chloride is on the burette scale. Now burette scale means we need to set it up to either 00 or some perfect reading. You can say a round figure. Now record the initial burette reading. Use a measuring cylinder to pour 25 centimeter cube of solution F in the conical flask. Now we are pouring NaOH solution F into the conical flask, which we have already rinsed with distilled water. Now stand the conical flask on a black or a dark colored sheet of paper. Slowly add aqueous aluminium chloride from the burette to conical flask while swirling the flask until the mixture in the conical flask just starts to become cloudy. Okay, record the final burette reading. Now refill the burette. Second experiment says refill the burette with aqueous aluminium chloride. Run up some of the again it's the same process, but now we are using solution G. Now this time again we are using the measuring cylinder to again pour 25 centimeter cube, but then G in the conical flask, and same process is repeated. Experiment 3, now what is happening is we are repeating the same experiment. You can always pause the video and read the whole question. The same thing, but use the measuring cylinder 25, pour 25 centimeter cube of solution G in the conical flask. Add 5 drops of thymolphthalein indicator to the conical flask. Turn the conical flask on white tile and slowly add aqueous aluminium chloride from burette to the conical flask while swirling. record the final reading. Thimerphthalate indicator changes color during this, and we are going to record that final reading. Okay, here are the diagram for the experiment 1, 2 and 3 given for the burette readings. It says experiment 1 final reading and initial reading. So let's have a look for experiment 1. What is final reading and initial reading? Initial reading is, we can see that it is 1.3 and final reading is 14.7. So 1.3 and 14.7. So initial reading is 1.30 and 14.7. Even if you don't write it 30, that's fine, but one decimal place for sure has to be written. We need to understand till one decimal place we have to write. Okay. Second experiment, when we can see that the initial reading is 2.7 and the final reading is 29.5. So it is 2.7 and 29.5. So 2.7 and 29.5. And let's have a look at the reading of experiment 3. Here it is 0.4 and 28. So 0.4 and 28.0. Don't forget writing 0.0 because we need to write it for the single decimal place, that is to one decimal place we need to write. Now volume of the aqueous aluminium chloride added in centimeter cube. So we need to find out the difference for the two readings and write here. Now this we know it is 13.4. The next is 26.8 and the third one is 27.6. So here are the three readings which we have got from our burette readings diagrams. We are shown in experiment 3 an aqueous sodium hydroxide in the conical flask is alkaline. At the end point, the mixture in the flask is no longer alkaline. State the color change seen at the end point in experiment 3. Now it clearly says that the initial pH, that is initial solution, was alkaline. At the end it was no longer an alkaline, and we have already added a thimerphthalate indicator. Now thimerphthalate indicator in alkaline solution is blue, and if it's no longer alkaline it changes colorless. So the color change is going to be blue to colorless. Now question C is state why the conical flask is swirled as solution F is added in the experiment 1. The simple answer is that the reactants should mix thoroughly so that the reaction is seen properly. So the reactants should mix properly. It should mix, or to mix the reactants also we can write that to mix the reactants we are swirling the conical flask continuously. The next sub question D is suggest why the conical flask is placed on black or dark colored paper in experiment 1 and 2. Now it's clearly written that during the experiment the solution will turn cloudy gradually, cloudy, or you can say it will turn white, or white precipitates are formed. So to clearly see the white precipitates, formed, the white precipitates formed, it is placed on the dark colored paper. So to see the white precipitates clearly which are formed during the experiment. So here we write the explanation this way. E question is explain why the measuring cylinder is rinsed between experiment 1 and experiment 2. Now if you remember the procedure, you can go back and read the procedure again. It says that the measuring cylinder is first used for solution F and then we use solution G in experiment 2. Now if the measuring cylinder is already used for solution F, it would be having some droplets of the solution F. So we need to rinse it so that we can remove the solution F from the measuring cylinder, and that is why we rinse it to remove it, and then we use the solution G so that the concentration of the NaOH, that is with the solution, doesn't mix and we get the accurate reading. Okay, the next sub question is explain why the measuring cylinder does not need rinsing between experiment 2 and experiment 3. Now the reason is that we are still using the solution G only in experiment 3, which was used also in experiment 2. So we don't need to rinse it. So we can just write that the same solution G is used in both the experiments, Now that is how we can write here. Next sub question, let's go ahead. F, it says compare the concentration of solution F used in experiment 1 and the concentration of solution G used in experiment 2. For that, now we need to have a look at the reading here. Now if we compare the readings of experiment 1 here and experiment 2 here, we can see the reading is exactly double. Here the experiment 1 it is 13.4 and double the reading is experiment 2, that is 26.8. Now NaOH used is in the burette. Aluminium chloride is used in the burette and the solution of NaOH, that is F and G, are used in the conical flask. So if the aluminium chloride used is double, obviously the concentration of NaOH solution G also should be double. So how are we going to compare the concentration of solution F and G? So we can write that the concentration of solution G is a double the concentration of solution F. Both of it are NaOH, but then as double the reading, the aluminium chloride is required to see the precipitates, so we can say that the concentration is double. Now if it says explain your answer, then we can say that the aluminium chloride solution, or even you can say that the reading is double. The aluminium chloride solution required is double in experiment 2. Even you can write that the reading of experiment 2 is double, that is also fine. So here is the explanation given for 3 marks. Now we need to understand that 1 is for stating that the concentration of solution G is more. Second mark is for giving the reason that why did we find that the concentration of G is greater, and the third mark is for that it is a double, not exactly. If we just end up writing the concentration is more, we'll only get 2 marks, but if we specify that concentration of solution G is double, then we get the third mark. Now the next G question is calculate the volume of aqueous aluminium chloride required when experiment 1 is carried out with 10 centimeter cube of aqueous sodium hydroxide instead of 25 centimeter cube. So let's see what is the reading of experiment 1. It is 13.4. Now if we are using 10 centimeter cube instead of 25 centimeter cube, it's going to be 2.5 times less. So we need to divide 13.4 divide by 2.5. So 13.4 divided by 2.5 is 5.36 centimeter cube. Now you need to mention the unit also, because it's clearly written the earlier reading is centimeter cube. Now the sub question H, this is the last question of question 2. In all the 3 experiments, it is more accurate to measure the volume of aqueous sodium hydroxide using volumetric pipette instead of measuring cylinder. Explain why it is not possible to use a volumetric pipette to measure the volume of aqueous aluminium chloride in this experiment. Now we need to understand that if we are titrating with aluminium chloride, then it's not going to be a fixed volume of aluminium chloride. We need to find out what volume is needed, and if the volume is not fixed, it's going to be variable, then we need to use the burette. If we have to use a fixed volume, then only you can use the volumetric pipette, say 10 centimeter cube or 25 centimeter cube. Accordingly, we'll use the volume of the pipette or the size of the pipette for the requirement of the volume. So we can write here that the volume of aluminium chloride volume of aluminium chloride is not fixed and it is variable, which we are going to measure. So this is how we write the experiment answer for explanation for this. And here also the question 2 ends. Let's go ahead with question 3. And starting with question 3, it says a student tests two substances, solid H and solution I. Now remember, this is solid H, this is solid, and I is a solution. Okay, let's go ahead with the solid H information. It's written clearly, solid H is barium carbonate, that is we have Ba2 plus and CO3 2 minus here, and complete the expected observations. The student adds an excess of dilute nitric acid to the sample of solid H in a boiling tube and tests any gas produced. Now, what is the observation? The observations are here. You can see there are 2 marks, so you can't just end up writing one observation. So, first observation is that the bubbles or fizzing is seen. The effervescence also you can write. So bubbles is seen, and the gas produced turns lime water milky. The reason being is that it's a carbonate. Now on adding acid is going to produce carbon dioxide, and if we test the gas, passing that gas to the lime water is going to turn milky. So that is how we are going to test the gas produced. Okay, identify the gas made in A1. So here we need to write that the gas produced is carbon dioxide, CO2, or carbon dioxide name you can write. Next part says the solution produced in A1 in solution J is solution J. The student divides the solution J into 4 approximately equal portions. I need to understand that to the barium carbonate, what have we added? We have added nitric acid. So the solution J should be barium nitrate now, where carbon dioxide is evolved. So now we need to understand we have Ba2 plus and NO3 minus in the solution J. The student carries out a flame test on the first portion of solution J. Now if we are carrying out a flame test, the barium is going to give the flame test, and let's see in the test of the flame test that the color of the barium's flame should be what? It is light green. So let's write light green color for the solution. Light green observation, yes, that's the flame will observe. Light green flame, light green colored flame is seen for Ba2 plus, that's barium. Okay, the next part is to the second portion of solution J, the student adds a few drops of acidified aqueous potassium manganate. Now the solution is colorless. You need to remember all the barium solutions are colorless, and if we add an acidified potassium manganate, and if it gets oxidized, any of these species present here gets oxidized, the color will remain colorless, that is the pink color of the potassium manganate is decolorized. But here none of the element or the species present is going to get oxidized, so the pink color of the potassium manganate is going to stay as such. So we need to write that the solution turns pink. We need to write it, the solution turns pink, because the pink color of the potassium manganate is seen in the solution. The D question is to the third position of solution J, the student adds a few drops of dilute sulfuric acid. Now what happens is that Ba2 plus present is going to react with the sulfate of the sulfuric acid to form barium sulfate, which is white precipitates. So the observation is white precipitates. Now if you have a look in the cation anion table, the test of the sulfate is given by the barium nitrate. Barium nitrate, acidified barium nitrate is added to any sulfate ions, it gives white precipitate. So here the reaction is reversed. We are adding sulfate to the barium solution. So again we'll get the white precipitates. In the same way we can write the whole word, a word that is precipitate rather than the short form PPT. Okay, yes, to the fourth position of solution J, the student adds about 1 centimeter depth of dilute nitric acid followed by a few drops of barium nitrate. Now if you again recall or go to the table of anion test, this is a test of sulfate, but then we have already changed the solution to barium nitrate, and that's why it's not going to show any color change or any precipitate. So we can write no change or no reaction here. Let's go to the next part. Next part is yes to the test. Now these are the tests on the solution I. Now table 3.1 shows the test and the student's observation for solution I. The student divides solution I into two portions. Okay, the two tests are given. The first portion of solution I, in a boiling tube add 2 centimeter cube of aqueous sodium hydroxide and warm the mixture. Test any gas produced using damp red litmus paper. Red litmus turns blue. So now if the red litmus paper turns blue, obviously the gas produced is ammonia gas. Let's go ahead with the test 2. In the second portion of solution I, in a boiling tube add 1 centimeter depth of dilute nitric acid followed by a few drops of silver nitrate, and white precipitates are seen. White precipitates with silver nitrate is a test for chloride. You can go down and again check on the cation anion test table. It is Cl minus test which is given by the silver nitrate. So identify the gas produced in test 1. As we have already found, it is ammonia gas produced which turns red litmus paper blue. So we have already written ammonia. State what is observed when the gas produced in test 1 is tested using damp blue litmus paper. Now the point is that ammonia itself is basic, so the base itself is not going to turn the blue litmus to any other color. It stays blue. So we can just write stays blue color, or you can also write that no change in the color of the blue litmus paper. You can just go ahead with that part. Okay, so now if we have a look at this test, it's an aqueous sodium hydroxide is added and then the gas is produced on heating or warming, right? So let's see what is this test for in the cation anion table. Here we can see that ammonia NH4 is produced on warming. It's written for NH4, that is ammonium ion. In that, if ammonia gas is produced on warming, so here in our solution we have added NaOH and the ammonia gas is produced. Now that is also a test of ammonium ion, that on adding any alkali and warming, if ammonia gas is produced, then it's ammonium ion. So identify solution N. So we have ammonium ion definitely, and we also have chloride ion, so it is ammonium chloride. You can also write in the name form, that is ammonium chloride. Any ways you can write any one method can be used. It can be word or it can be the formula, but I prefer that if you are not sure about the formula, you better write the name in the words. Okay, let's see the last question 4, which is all about planning. In question 4 it says bismuth is a metal that has a reactivity similar to that of copper. The ore bismite contains the compound bismuth 3 oxide, that is Bi2O3. Now bismuth 3 oxide is insoluble in water and reacts with dilute acids to form an aqueous solution of a salt. Okay, the ore bismite contains no other compound that are insoluble in water and no other compound that reacts with acids to form aqueous solutions. Okay, describe how you would obtain a sample of bismuth metal starting with a large lump of the ore bismite. Okay, so you have got a large lump of the ore bismuth, from which we need to obtain the metal bismuth. Now metal bismuth, here it's written, it has a reactivity similar to that of copper. Now here one more information is given, that bismuth oxide is present in the bismuth ore, which is insoluble in water but reacts with dilute acid. Okay, so along with this information, when it's written its reactivity is similar to copper, then we can extract with the method of a copper, like by adding carbon or anything. But here I feel that using of water and acid, I find it more suitable, so we can use that also. But yes, on adding any carbon to the bismuth oxide and heating it, the carbon is going to replace bismuth and carbon dioxide is forming, and the bismuth will be formed. That also method can be used. Okay, so fine, let's go ahead and write that. Okay, so starting with the ore, with large lump of the ore, fine. So what we need to do is that first thing is that take the lump of ore, and crush it in powder form, you can write, but crush it in powder with the help of pestle and mortar is what we use for crushing. So here with the help of pestle and mortar, that's what we can. Now after obtaining the powdered form of the ore, what are we going to do is that add any reactive metal or carbon, then it's going to replace out bismuth from the bismuth oxide. So but then to get bismuth oxide, first we'll have to remove all the other insoluble impurities which are present along with the bismuth oxide. So what we can do is that add enough water to the ore to remove any other impurities, and now if bismuth oxide is insoluble in water, the second step is to filter the solution. So filter the mixture. Now we need to understand that the residue is going to be bismuth oxide because that is insoluble in water. So we need to understand that whatever treatment we are going to do is with the residue. So now let's understand what are we going to do is that add carbon or add any other reactive metal to it, so that on heating it displaces out bismuth from the bismuth oxide. So what I am writing is on adding carbon. Why? Because carbon changes to carbon dioxide on reacting, and carbon dioxide is a gas which easily escapes out. But if we add other metal, it's going to form the metal oxide and bismuth metal. Now again, it's little difficult to separate the other metal oxide and bismuth because one of it might be liquid. Yes, so fine, what I'm going to do is that add coke or carbon. Now coke is a purer form of coal, that is almost pure carbon. Coke or carbon to the residue. Now we need to specify here to the residue and heat. We need to heat it properly and heat. So I'm specifying it heat. Now what is going to happen is that carbon dioxide will escape and the metal will be formed. Now we can also specify the apparatus like heat in a crucible if we are doing it in a lab. So heat in a crucible, or you can even write a clay tray, that is also fine. We need to have any other material which can withstand high heat. So I'm writing heat in a crucible. Then what is going to form is that the bismuth 3 oxide reacts with carbon to form carbon dioxide, So the reduced ore, the ore is getting reduced. So understand, the ore is getting reduced as losing oxygen. So the reduced ore forms bismuth metal, and this is how we obtain the bismuth metal. So this is how you're going to write in the stepwise form, and this question is 6 marks. So don't forget mentioning the name of the apparatus, what are you adding, why are you adding. For example, if you are adding, we can't forget writing about the filtration of the mixture, and here also we need to understand that we are adding coke to the residue. Specify where are you adding the coke. So if you have written all the specificity, then out of the 4 points also you're going to get 6 points. And here our question paper 6-2 ends. I hope all the questions are very clear.